consumer internet startup for retail investors. At Cake, he designed and implemented a portfolio recommender system and a stock fund rating system. He's co-authored 5 patents and several research papers. He holds a PhD in chemical physics from Princeton University and a Master's of Science in Chemistry from the Indian Institute of Technology, New Delhi. Please join me in welcoming Dr. Manu Sharma.
Thank you. I would like to begin my talk by asking a question to the audience. Show of hands, how many people in this room have a LinkedIn profile? That's pretty good. That's what I thought. How many of you have Googled yourself lately? For those of you who haven't, it's okay. We all do it. You can admit it. After the talk, whenever you have time, go back, Google yourself, and see if your LinkedIn profile shows up among the top results. The reason why I'm starting kind of with this theme is because LinkedIn is your professional profile of record. We are all professionals, and now essentially, this is our way. LinkedIn is your way to represent your professional self to the rest of the world. When people look for you in a professional context, they will either Google you or LinkedIn, go to LinkedIn and search for you. So it's important for you to keep that profile up to date. And as I was introduced here, I'm running the data science team at LinkedIn. And if you'll notice in the title of my talk, I have 5 keywords. And that's what I'm going to talk to you today about. So I'm going to talk a little bit about LinkedIn, talk a little bit about data science, what it is and what it means at LinkedIn, and how we use our data at scale to innovate and draw insights for our business. So let's start with LinkedIn a little bit. So LinkedIn is the world's largest professional network, and our mission is to connect the world's professionals and make them more productive and successful at what they do, whether it is looking for a new job, new career opportunities, or making you more productive at your day-to-day job. How do we do it? We use our data to build compelling products that our membership uses in order to give them the best intelligence of what's going on in their industry or sector, or to match their talents with the appropriate opportunity, career opportunities, new jobs. So a little bit more about LinkedIn. The company was founded in 2003 by Reid Hoffman. We are a top 50 site, number 31 in the US, number 34 worldwide, according to ComScore. We have over 120 million members on LinkedIn. Now this is an interesting one. It took us 500 days for us to get to our first million members. Any guesses on how many days it took us to get to our latest million? 3 days. Close. We did it in less than 6 days. We are adding 2 new members every second. Think about that. Since I started my talk, we've added 600 new members. And to reiterate the point that LinkedIn is the professional profile of record, just to give you a quick stat, we did over 2 billion people searches in 2010. That's a massive number. Oh, and that thing in May, IPO. Who's on LinkedIn? We have executives from all of the Fortune 500 companies. 8.5 million small and medium business professionals on LinkedIn. We have 9 million recent college grads. The average household income is $107,000. And 42% of everyone that's on LinkedIn is what we call a decision maker. So we've got the web's most affluent demographic on LinkedIn. And we are really international. It's not just in the US. Over half of our members are from outside the US. We are with representation in over 200 countries and territories. We've got 26 million members in Europe, 11 million in India, and our membership growth is accelerating. We're available in 9 languages and more to come. How we make money? We have got most people actually don't know this about us. We've got diversified multiple revenue channels. So it's not just online advertising, although it is one part of our business. But we make money from premium subscriptions. That is, our members buying either a pro package or a job seeker package, subscription package. Self-serve ads, that's essentially, you could go to LinkedIn and say, I want to run an ad campaign for $20 a month and target a certain audience. You can do that. Hiring solutions, that's our corporate solutions. We work with large corporations, and we essentially have this massive data set of our member base, which are not necessarily looking for active jobs right now, but they're passive candidates. And that's one way in which we connect talent with opportunity. And marketing solutions, that's essentially display ads that you may see on the site. Some of those are larger in size in terms of deal size, so we work closely with corporations for that. Let's talk data science now. Let's start with data. So what is data? I was trying to figure out how to introduce the subject of data science, and I thought it might be interesting for us to take a step back and understand what data really means. So according to the Webster Dictionary, data is factual information used as a basis for reasoning, discussion, or calculation. Information output by a sensing device that includes both useful and redundant information that must be processed in order to be useful, or information in a numerical format that can be digitally transmitted. And after I built this slide, I came across another definition, one that Reid Hoffman likes to use. Data is the new black, but we'll stick with the first one. By that rationale, one could argue weblogs is data. But technically that's true, but that data is not useful to us in any way until you parse it, you normalize it, you standardize it. Once you've done that, that leads to information, right? So data in a standardized and normalized format is information. And then you take this information and turn it into knowledge, right? This is what I like to call the equivalent of know thyself, right? Knowledge in terms of dashboards and reports that you measure on an ongoing basis is essentially knowing your business and knowing your data. How am I doing on a day-to-day basis? How are my different product lines doing? How are my revenue lines doing? If you can't measure it, you can't fix it. And you sure as hell can't improve it, right? So you need a baseline. And I want to emphasize, I think traditionally BI and business analytics is kind of, this is the domain. This is how most traditional BI groups would use data. But we go definitely much, much further than that. You can take the knowledge that you gain from here in order to generate insights, doing more sophisticated things like attribution analysis. If you sort of launch a new product, how does that impact the overall user engagement or user behavior on the site? Ultimately, though, the end goal for a data science team is to get to wisdom, right? Use data to generate wisdom that drives the business. That's what we want to do at the end of the day. So I'm going to talk a little bit about all of this, how we do this. And so data science then is really an art, I would argue, of using multiple data elements in clever ways to solve iterative problems that when combined solve a data problem that might otherwise be intractable. That's a lot of words. But what do you need in order to be a data scientist? What makes a data scientist? A data scientist needs to have a wide variety of skills, right? So you start with curiosity. I want to ask the right questions. I have all this data. What can I do with this data? Whether it's to generate insights or to build products. Oh, wouldn't it be cool if I could build this stuff with the data? Or I wonder what information my data has. So to ask those questions, to have the right intuition, to formulate those questions, and then to go after the types of data. There's so much data that we have access to. What particular data elements should I look at in order to ask these questions? How do I go grab that data, gather that data? How do I standardize that data? This is extremely important, and I'll give you guys an example of why data standardization is extremely important. And then, running stats on top of that. What types of models you could, start with a simple regression model and go more sophisticated, like machine learning methods like support vector machines, or using econometrics methods, like panel data approaches. But you have to know all of these things, right? You have to have this gut intuition and this sort of knowledge about all these methodologies, and then eventually, being able to build models to do predictive modeling, and then finally to visualize this in data in compelling ways. Because if you're not able to do all of this, then you're pretty much the only kind of group or person who can understand what you've done, right? So you have to be able to communicate effectively. And so just to give you guys a brief idea of the kinds of technologies that we use in our day-to-day life, our normalized data from our data warehouse sits in an Aster data and an Oracle data instance, data warehouse instance. With Teradata soon to come, we're in the process of migration. And we use a lot of our homegrown stuff, but we use open source solutions as well. So we use Hadoop quite a bit. In conjunction with Voldemort, Kafka, and Azkaban, these are our homegrown inbuilt solutions that are also now publicly available and open sourced. And really the paradigm here is turning more and more to iterate in Aster and Oracle. So iterate in the data warehouse and build in Hadoop. So especially when we are doing long-term deep dives, when we are doing sophisticated modeling, when you're doing forecasting models, we iterate in the data warehouse and build it in Hadoop. We use a bunch of other stuff like Python and R for some of our statistics. We use something called Pig and Hive, that is a layer that sits on top of Hadoop in order to get the data in and out of the Hadoop file system. So Hive is like a SQL-like interface. Pig has its own language called Pig Latin, which we use. We use MicroStrategy, SQL, and again, LinkedIn Reportal is our homegrown solution for reporting and dashboarding. We use crowdsourcing for standardization, in addition to a lot of algorithms that we develop ourselves. And then we use a bunch of different technologies like Gephi and processing and prefuse, and we've just started to use a little bit of Tableau for the visualization piece. Gephi is actually an interesting story. We discovered it about a year and a half ago in the data science group and started to play around with it. It does this really cool sort of clustering and visualization, and you guys will see an example of that in a minute. And then we said, oh, this is really cool, and we want to use this at scale. So we developed what we call in-maps, which is so visualization of your social network. And it's really compelling. And then we figured we should just hire the guy that did it. It was this one person in France. We just made him the offer, and now he works for us. So as a data scientist, if I can back all of this stuff that I just said and say, this is the future, data science is the future, the demand is going through the roof, if I can back it up with real data, that would kind of be pointless. So according to LinkedIn data, the percentage of all positions that are analytics or data science as a function of all the positions that we have access to on LinkedIn is literally going through the roof. And it's no surprise, it's hard to find people with such a massively broad skill set. Well, what do we do with data once we have the team in place and once we have the data in place? Well, you can do two things, and both of which we do. You use data to build compelling products, right? So even within that paradigm, there are products that are built specifically on the data. And we go a little bit beyond that, which is essentially we try to weave data into every single product. So a continuous theme I think that you should take away from this is, in order to be a data-driven company, data has to be in your DNA in every single product, right? So we build innovative data products, and we draw insights from our data that ultimately allow us to kind of drive the business, right? But before we can do any of that, there are a few challenges that we have to overcome. And now let's talk about scale. So scale is a big, big deal for us. some algorithms and sort of analyses that you can do with 1 million rows of data doesn't really scale when you have billions and billions of rows of data. In particular, when you have something like LinkedIn, which is a network, these things become extraordinarily complex, right? So I just mentioned that we have 120 million members. Now imagine you start building edges between those nodes. When people connect to each other, you have billions of nodes. And that number massively explodes as your member base grows, right? So scale is actually an important problem. So big data, big challenges. A lot of times out-of-the-box solutions do not work. So what do you do when that happens? You don't have much of a choice. You have to build your own, right? To give you an idea of the scale of our data, we crunch through 75 terabytes of data every day to produce some of the recommendations that you see on LinkedIn. And that's not all recommendations. That's just one set of recommendations, right? To give you an idea of how far we have come, right? About two and a half years ago, when we first launched our recommendation products, the people recommendation, which is people you may know, we were able to push it once every 2 months, right, for our entire member base. And 2.5 years ago, we had less than half the members, like a third of the members probably. And we would compute these scores for members. I think we did 200 per member, and we could only do it once every 60 days. And we came up with this very clever algorithms of displaying the results so that they always seemed fresh to the member base, because we used a Monte Carlo approach. We would, out of the 200, we would pick 5 at random, and the likelihood of anyone being picked was proportional to the probability that the two people knew each other, right? So that kind of kept this freshness aspect to the data. Now we do it every day. So in the last 2.5 years, we have gone from 35 million members to 120 million members, and we are pushing this every day. We were able to do it every 2 months for 35 million. Now we can do it every day for 120 million. We process over 10 billion rows of data every day. We have real-time, up-to-the-minute reporting for some key metrics and events. And most of our web track events, clicks, impressions, they're tracked, updated within the 15 minutes of happening. So web track is up to the date every 15 minutes, delayed by 15 minutes at the most. So how do we do this, right? So like I said, we had to build a lot of our solutions in-house. To give you an idea, 120 million members and billions of connections between those members. If you go to LinkedIn and search for someone and then click on their profile page, we're instantly able to tell you that you're within 3 degrees from this person, how you're connected to them. How do we do this in real time? We built Project Voldemort, which is our implementation of a distributed key value store. It does one thing. It does it really, really well. I just said in my previous slide that we are able to, we have up-to-the-minute tracking for some key events. Think about that. In a minute, a latency of 1 minute, we track every single click, every single ad impression, every single impression that a member sees on our site. Within a minute, even if you're logging it properly in real time, how do we actually get it from the live production site into our data warehouse, or wherever, into an ODS, or into a stream? How do we do it? We built Kafka. Kafka is our fire hose. It's basically a real-time, high-throughput messaging system that just processes and throws every single thing that's being tracked, and then we pick up from that whatever we care to pick up for up-to-the-minute reporting. When you search for someone, the search results are instantaneous, right? So you're searching for a person, you see their profile, or you see a bunch of results. There's a ton of facets that you can then filter this data by. So, show me everybody that only works at Teradata and who went to college at UC San Diego and who is now living in the Bay Area. How do we do it in real time? Bobo, that's our faceted search technology that we built on top of Lucene, and a whole bunch of others, right? So this is, we build all these things, we use them internally, and they're now available open source for the rest of the community to use. So now that we have all of this in place, let's talk about innovation. Let's talk about building products with data. What data do we start with? Well, all of our members have profiles on LinkedIn, and those profiles have a lot of data on them, right? So we essentially take all of that data, and then we use all of this data to build different products. Before you can actually do that, there is one tiny problem. You have to make sure that the data is clean and usable. So let me give you an example. Here's an example of a person who works at IBM as a software engineer, and then you see there are two titles, software engineer and SW engineer. There are two descriptions for the company, IBM and IBM Research. How do we know that they're the same thing? Right? It's important. That's important. It's important for me to know that SW engineer is actually the same as software engineer. Any idea how many different variations of the word software engineer do we have in our system? $2,000? That's actually the right kind of ballpark. We have over 6,000 different variations of the word software engineer. And we are able to standardize them. We're able to say that they're all the same title. Any takers on IBM? How many different variations of IBM do we have? It can't possibly be 6,000. Can it? So anyone else? 100? 8,000. We have 8,000 different ways of saying IBM. Right? And then we're actually able to, in the back end, say they're all the same company. There's all international business machines. This is a combination of algorithms as well as crowdsourcing. But now that we have this data, we've solved this problem, we've cleaned the data, we've standardized it, what's the easiest product to build? Amazon did it really well, collaborative filtering. People who viewed this profile also viewed that profile, right? Actually, this is a really, really good way of doing search. If you guys are looking for a type of person, go find that person and follow this browse map, right? Because this is, again, a way of kind of crowdsourcing. People who are looking for this type of person are also looking for that type of person. And like this entire list is the data science team at LinkedIn, and I took this from my profile, right? So if you're looking for a data scientist, just find one and then follow the path. But that's not the most important product that we've built. The most important product that we've built is our people recommendation, people you may know. Now, I don't think most people know this, but people you may know was actually built at LinkedIn. We are the ones that invented this product. And interestingly, the person that invented it now works for Teradata, actually Teradata, I should say. So that's kind of interesting. But once you have this clean data and user engagement, you can really, really begin to leverage that data to benefit the user. So the two examples that I showed you earlier were products that are built on data. So you have this data and you say, I want to use this data specifically to build a product, right? But the flip side of that, the other side is, I want to make sure that every product that I have on the site should be built with data, should have some element of data algorithms into that product, right? So let's say this is your home page. Let's say what percentage of these different parts of the page, different products on the page, do you think come from data? So this is people recommendation. Here's some stats, more stats, jobs recommendations, groups recommendations. These are your network updates. And this is a product that we built, which is called LinkedIn Today. And LinkedIn Today, for those of you who don't know, is basically a way to tell you, here's things that are relevant for you, that are happening in your industries, in your functional areas, that you should be looking at. So how many of these things are data-driven? All of them. Every single one of them, right? And I don't mean like, okay, people do stuff on the site and that shows up in your network update stream. That's not really data-driven. I mean by data-driven is we want to apply algorithms on top of that and say, what type of things do you actually care about, right? So that's what I mean by that. And a new data product that we recently launched about 6 months ago at Strata in Santa Clara is called Skills. So, this is a talent economy. It's important for us professionals, to be able to put our best professional foot forward and to tell the world, hey, this is my expertise, this is my skills. Well, you could argue that we already do that in our profile, but let me walk you through, how we built this product and make a compelling case for why it's important for data to be standardized once again. So how do we do it? We start with your profile. We look at specialties, right? So this is kind of what you've told us about yourself in a free-form text blob format. We extract the keywords, we dedupe the data, normalize it, standardize it, and then that gives us a standardized data set for skills. But this is important because once you have standardized data, then you can do a lot of cool stuff with it. Here's a snapshot of a Hadoop skill page, right? Now, since Hadoop is now standardized in our system, we can say, oh, what are the related skills to Hadoop? Like if I want to learn Hadoop, what are the other things that I should care about? This is based on people's description. People who know Hadoop also know these other skills. Who are these people that are experts in Hadoop? What companies do they work at? And how's Hadoop doing as a skill? It's the 97th fastest growing skill. Hot skills for the future. This is it, right? What are the other skills that are related to this? You can't do any of this if you don't have standardized data. Like that free-from blob data, you could never do it with that, right? So standardized data is the key to building compelling data products. Let's look at the universe of skills. So these are all the skills on LinkedIn today, right? And they're clustered by co-occurrence. If the same person has 2 skills, they get an edge. Each node on this graph is a skill. And it kind of makes sense. Here's a bunch of tech skills, design, sales, HR. Okay, let's take a deep dive into technology. What does technology look like? Java, Ruby, Python, programming, scripting, C++, database, SQL. Let's take another deep dive, a deeper dive. And now you get to see the big data skills, MapReduce, Hadoop, HBase, EC2. Let's take a step back. See that blue cluster over there? That's what we call our bullshit cluster. Let's see what skills they have. Hard worker, attentive to detail, revenue improvement. So you couldn't do this without standardized data. Now you can identify these people, right? That's pretty cool. All right. So now let's look at insights. So how do you use the data to draw insights for the business and ultimately drive the business? It starts with reporting. Obviously, if you can't measure it, you can improve it, and you sure as hell can't fix it. So reporting is a key element to this. We do a lot of A/B testing. So we deploy software on a very regular basis. We're always building and iterating on new features. I think when you're building the first version of a product, gut becomes very important, and you build something that kind of feels right. But once you have done that, it's important to always iterate and improve. And there's no better way to iterate and improve than to do A/B tests, to let your users tell you what's working and what's not working. Now, at any given point in time, we've got hundreds of A/B tests running on our site, hundreds of them. How do you ensure that they don't overlap and contaminate each other? You have to have orthogonal tests running. So you've got a limited set of members, but how do you ensure you have an orthogonal set of member base anytime that you run tests? So we built our own A/B test platform, and that ensures that tests are always orthogonal, never contaminate each other. And then we do a bunch of really interesting stuff. Demographic trends, I'm not going to talk about that a lot here, but I'll show you guys some examples, hopefully, that you'll find interesting in addition to the bullshit cluster. And then really to understand how people are using your services and products, what do they want, what are the different use cases in order to tailor and customize their experience on the site. That's ultimately what adds a lot of value to the user. If you see a user coming to your site and you can tell them, I think this is what you want and I'm going to give it to you, and not have like the same experience for every user, like that's important, right? So how do we do that? And then ultimately that's what drives the business. So let's start with the financial collapse of 2008. This was obviously unprecedented. There was a lot of talk going on about what happened to the financial industry. People who worked in the financial industry, there was speculation that they either left the industry altogether or went back to school. Like, this was such a systemic meltdown that people said, this industry is completely devastated. But guess what? They're all still around. They didn't go anywhere. They just went to other financial institutions. Here's another interesting one. People talk about, professionals in the Bay Area change jobs more frequently than the average worker. Well, we got the data to prove it. And guess what? It's true. So here's what I'm showing is the average number of jobs or positions held by any professional within the first 10 years of their graduation. And you can clearly see that the Bay Area people move jobs, change jobs more quickly than people in the rest of the country. Now, what's interesting about this data is also, even though the site was founded in 2003, our members actually tell us about their entire work history. So we have data going back to the 70s in this case, right? So that's pretty cool. What are the hot jobs these days? I don't know, some of you may have seen this. If you're not a ninja these days, you're not so cool, right? Code ninja. If you're a guru, on the other hand, yeah, that's not so. That's getting out of fashion. Ninjas are in, gurus are out. CEO names. If you're named Peter, Bob, Jack, Bruce, or Fred, you're likely to be a CEO. So congratulations. On the other hand, if you're named Chip, you're probably in sales. Nothing against the chips in the room. Just saying, that's what our data shows us. And then ultimately, talking about wisdom, using data to drive the business. Obviously, I can't elaborate a lot on these things, but I leave you guys with a glimpse into kind of the kinds of problems that we are trying to understand and tackle with our data. What is the value of an action that a user takes on the site, right? So are all actions created equal? Or in other words, are all page views created equal? When we as a networking site, actually, this is a really interesting use case, because anything that you do on LinkedIn is not limited to you. It percolates through the entire network, through the entire ecosystem. And I want to identify different actions that influence your network differently, right? So perhaps you post an update, a bunch of people care about that. They might like it or share it or whatever. If you update your profile and say, I have a new job, right? There's probably more interest from your network in that. Oh, you got a new job, I wonder what that is, and they'll go view your profile, right? So these different actions have different consequences. They drive different behavior from the network, so they propagate differently through the ecosystem. What are early behaviors on the site that I can use to predict future engagement? So this is not correlation. I want to build a rule book that says every new member should do these 5 things, and if they do it, then they're going to be engaged in the future. They're going to come visit the site frequently. They're going to get the most value out of the website. There's a little bit of a struggle in this one because there is selection bias here. You could have people that are self-selecting into using certain products a certain way, right? Maybe there's a group of people that are looking for jobs right now, and they're using a certain subset of the site in a certain way. I obviously can't make every new member look for a job, right? So you have to control for these biases. You have to do more sophisticated analysis in order to understand what ultimately remains as a true sort of close to causal behavior, I would say. You can never get to causality or causation based on analysis. You have to do experiments. What you can get to is you can get very, very close to good testable hypotheses that are almost causal, right? So that's one thing. What is the value of a user? Just like actions, are all users created equal? Probably not, right? I mean, I have a bunch of stuff going on in my professional network around me, and I showed you a snapshot of my homepage where there were a bunch of different updates from people, right? Well, different people care about different types of updates. As I just said, if you update your profile, there's probably more interest in that rather than you posting kind of a story or sharing a link. But different people also care more about other people than, within my professional network, I care about Reid Hoffman's updates rather than somebody else's, right, who's not Reid Hoffman. So what is the value of a user? When Reid Hoffman posts an update, how does that propagate into the system? When Reid Hoffman shares an article, how does that propagate into the system? So understanding those types of, trying to identify influencers in your network whose activities you care most about. And that's to say, I don't care if you came to the site 6 months ago. If the day after you visited the site 6 months ago, there was an update from somebody really important, you should be seeing it, right? It should not just get lost in the stream of noise. And then, things like, again, this is something that people struggle with. If I have ads on my site and I drive traffic to the mobile use case, and I don't show ads on the mobile use case because it's not a good user experience, am I cannibalizing something? So, but it's really not that simple, right? What it is if mobile engagement actually enhances your site engagement, then the net you might actually be not as bad as you thought. So, those are some of the types of analyses that we are doing at LinkedIn to drive the business. Ultimately, though, what makes a good data team is the people. And so now I will take any questions. Thank you.
Okay, there we go. Please wait for the mic as well so the question can be translated.
What process or applications do you use to help manage your A/B tests?
So we have an internally homegrown solution that essentially ensures that anytime you run an A/B test, and this is not, we used to use mod of member ID, not the best way to do A/B tests. What we have now is a more sophisticated algorithm that ensure you can actually segment by sort of desired characteristics. That doesn't have to be member ID. But what ends up happening is that any given segment that goes into an A/B test is not skewed in any way by other A/B tests. So the test groups are always orthogonal to each other.
Question. I'm from Teradata, trying to figure something out. What's the value of Aster data? What kind of advanced algorithms or things are you doing that weren't possible before?
So let me repeat the question. What kinds of algorithms that were not possible before? Before what? Oh, before Aster data? I think the NPath is particularly compelling. So Aster has this sort of technology that allows you to do page flow analysis very, very easily. I think that's something that's been very compelling. We've also used, built our own user-defined functions using SQLMR, code it up in Java, install it in Aster, and then call it from a SQL environment, which is kind of interesting. I didn't show this here. Last year I did a blog post about the top buzzwords that people use on their profiles and how not to describe yourself like that, which was done using Aster, and I wrote a Java code that would just tokenize words and then do a count of them. So I would say NPath and SQLMR.
Given the richness that is available to you and that many answers lead to more questions, what approach have you experienced or have you taken in regards to prioritizing questions and knowing whether you should be looking into sales reps named Chip or some other area?
Could you repeat the question a little loudly? I couldn't hear it.
Sorry, the question being, given the richness of the data available to you, how do you prioritize which questions you will pursue, given that we're in the area where so many answers lead to so many more questions?
So let me repeat that, if I understand correctly. Given the richness of the data, how do we decide which questions we want to pursue? Let me just say this, like there's no dearth of good ideas in our team. Like at any given time, we always have a lot of different questions that we think are interesting and we want to answer. We kind of, from a practical standpoint, get together in a room and brainstorm and then figure out here's kind of the most interesting ones that we should be answering. So that prioritization exercise happens internally, and we also we work very closely. So the way the analytics team runs is we work very, very closely with product. So we constantly are interacting with those guys and trying to figure out what are compelling analyses that we can do for you guys. Not just building reports and giving you sort of dashboards and things like that, but like real deep dives that would have a high impact or move the needle for your product. So it's a combination of different things. We definitely have no dearth of good ideas.
Is your team also responsible for improving advertising performance?
The data science team is per se not mandated with that. We have a data engineering team that actually takes a lot of these algorithms and ideas and productionizes them. And we have a real-time recommendation engine that is essentially an optimization engine that optimizes ad CTRs. But we do have people from my team working on the ads as well.
Yeah, I just wanted to ask about the visualization you had of skills. Was that Gephi? And could you, yes, is that yes or no? And then how does that differ from processing? I mean, I guess I haven't.
So that was our own version of Gephi. So once we got Matthew, who's the person that wrote Gephi, Gephi is an open source software, and there were some licensing issues. So we basically got him. He rewrote it for us. So that was Gephi, yes. Processing, I don't think has nearly any ability, as far as I know, to do these complex sort of, Gephi in its backend has an optimization engine. Right? So you have a bunch of nodes that are connected through edges, and then you basically run a force algorithm on them. And nodes that are heavily connected attract each other, and clusters repel each other. And that's how you get that graphic. I don't think processing has any of those capabilities at all. Yeah.
So my question is around standardization. Can you talk about what technology you're using and whether you considered going externally into a Trillium or a third party that does that type of service?
So we've used a combination of different things for standardization. We do both crowdsourcing. We've used Samasource and Mechanical Turk, as well as our own technologies like algorithms with a bunch of business rules in them that standardize our data. In 2010, that was a big effort for us to get data to that level.
Thank you for the presentation. I was just curious, you had R on one of your slides, and I'd like to hear, I'm personally very invested in R and excited about where R is headed in the corporate world. Can you speak about the investment you make in R development and how you address some of the limitations of sort of the out-of-the-box open source R?
So in terms of investment that we make in our development, we are currently not at the stage where we are actively contributing back to the community. We're certainly using R for any and all modeling, all the way, GLMs and regression models and some of the sort of panel data approaches that I talked about. Once we have the data in the format that we need it, we use R to get sort of, if you have a bunch of independent variables, you're trying to fit a dependent one, what are the weights, like those types of analyses we do in R. Obviously the limitation is that, there are memory and capacity issues, and so you have to sample down. But so far we haven't really we can extract the signal from the sample down data in a statistically meaningful way.
You mentioned Teradata coming in as a data warehouse. How will that particular product fit into your data solution?
So the idea is for us to have all of our data raw and processed in Hadoop, and then the processed data will also sit in Teradata. So we will have data coming in from our production servers as well as the Kafka stream. We will store it in Hadoop as a snapshot. We will process it in Hadoop, and then the process data sits both in Hadoop and in Teradata. And then the difference would be retention. In Teradata, we'd have more sort of aggregate tables, and then fact tables will have shorter retention times, whereas in Hadoop, we'll have longer retention times. And that'll sort of, that's kind of the idea. In conjunction with Astrodata, we're moving away from Oracle as a solution.
You talked about the value of a user. I'm just wondering, given that it's likely your users have profiles outside of LinkedIn, do you guys consume any external data to consider what maybe the value of a user is?
That is a good question. So at this point, we do not. The only external data source that we use is Twitter data because we have a relationship with Twitter. But that's it. We do not, certainly don't use external data. It's a slippery slope. You have to get permissions from your members. So you can certainly use APIs from other social networks, but we care very deeply about privacy issues for our members, so we deliberately don't do any of those third-party or external data sources.
Okay, another.
So the question is, do you prove the business value prior to having the questions for the analytics? And the answer is no. We don't have a formalized process by any means of here's what you can and here's what you can't do. Like I said, it takes a certain personality. Certainly for my team, this is true. You have to have kind of that raw passion and like interest and just go for it, right? And we've done that a lot. And then every time we see something interesting, then it gets presented to Jeff and the executive staff. And then depending on the level of interest and excitement, we will either pursue it or say, okay, this is something nice to do. We'll come back to it as we have more horsepower and time.
So looking at those really cool visualizations, when do I get to track myself through some of those? My name's not Chip.
Say that again.
So those cool visualizations, as a user of LinkedIn, when do I get to see where I fit on some of those graphs?
So certainly show up at LinkedIn and we'll print you your professional network. By the way, we do this for everybody who comes to the company now, but it's in the works. I don't know what the roadmap says, but some of it is in the works for sure. In the meantime, you can go to linkedinlabs.com. And there are some of our sort of new technologies and things that we are experimenting with, visualization of your professional network or timeline, like how did you build your connections over time? Like there's some really cool stuff there. So if you just Google LinkedIn Labs, you should be able to see that link. Yeah, it's pretty interesting. And by the way, I should also mention that we have I believe it's the second Friday of every month where we have a hack day. And this is really where, Hack Day is where a lot of this stuff just comes out. Like the network visualization came out as a Hack Day project. There is a visual for timeline where it will show you how you connected to different people over time from different backgrounds and companies and colleges. Like a lot of this stuff just happens on Hack Days. People get together, they do something fun, and then the winner gets bragging rights and sometimes turns into products.
Any further questions? Well, if not, join me in thanking our speaker, Dr. Sharma from LinkedIn.
Thank you.
Please